Aloha and welcome. In this lesson, we're going to be talking about power supplies and troubleshooting computer problems. So as before, we're still in part one, CompTIA A plus core 1, 220-1101. The module objectives are, by the end of this module, you should be able to describe the methods and devices for keeping a system cool, select a power supply to meet the power needs of a system, demonstrate an organized approach to solving any computer problem, especially hardware problems occurring during the boot. And note, this is something that you'll see again in Network Plus and Security Plus as well, the systematic approach to solving problems. And you're also going to be looking at troubleshooting problems with the electrical system and troubleshooting problems with the motherboard, processor, and RAM. So cooling methods and devices. If the processor, motherboard, memory modules, expansion cards, and other components overheat, the system gets unstable and the components can fail or be damaged. Devices used to cool a system are CPU and case fans, coolers, heat sinks, and liquid cooling systems. General rules to cool the inside of a computer case include the following. 1, keep the case closed, keep the inside, clean the inside of the computer, and move the computer. Computer systems use a cooling assembly designed for a specific processor to keep temperatures below the processor maximum temperature. Good processor coolers maintain a temperature of 90 to 110 degrees Fahrenheit, that's 32 to 43 degrees Celsius. The cooler sits on top of the processor, just puts right on top. It consists of a fan and a heat sink. The heat sink uses fins that draws the heat away from the processor, and then that's dissipated by the fan itself. The fan blows drawn heat away from the CPU unit, and the fan gets its power by using the 4-pin fan headers on the motherboard. And you've got multiple fan headers around your motherboard. Thermal compound and thermal pads. Thermal compound or thermal paste transfers the heat by completely filling the gap between the processor and the cooling device. An alternative is to use a thermal pad, which is thicker than the thermal compound and fills large gaps better. They're more easily applied in size for the contact plate. It also removes the need to kind of judge, how much of a pea-sized amount of thermal paste is enough, because you don't want to use too much, you don't want to use too little. But you never want to use thermal pads and thermal compound at the same time. That's a no-no. And you never want to stack your thermal pads together. To prevent overheating, you can also install additional case fans. Most cases have one or more positions on the case to hold a case fan. Large fans tend to perform better than small fans. Some graphic video cards come with its own fan. Fan cards can be mounted next to graphic cards inside the case. Be sure to select a fan card that fits the expansion slot you plan to use. A RAM cooler clips over a DIMM memory module, and it may be powered by a SATA or 4-pin Molex power connector. So this is what the rear of your case looks like. The gap in the right-hand side is where your power supply is going to go. You can see it has a little ledge there for it to fit on. But right below it, that big honeycomb-looking area, that is where the fan goes. And you can see the screw holes that you've got for that. So that's where you would install the one in the back. Here is a picture of a liquid cooling system that pumps liquid outside and away from the components where the fans can then cool the liquid. This one is interesting. Notice how they have these big honking fans on the side of the unit. You're going to have fans throughout your systems in general, but you'll often have some in the front and some in the back. What you need to make sure is that you have them both pointing in the right direction, because you don't want them both sucking air in, because then you're just going to be bringing cool air in, but you're not going to have anywhere for the hot air to go. It's best to have one going in and the other going out. And you can experiment with that, but be careful, because it does matter what direction you point your fans there. Selecting a power supply. Reasons to replace this power supply include the following. A power supply fails, or a power supply in an existing system is not adequate and you need more power. When building a new system, you have the following options. You can purchase a computer case with the power supply already installed, or you can purchase your own power supply separate from the case. So important power supply feature considerations include the following. The form factor determines the power supply size. The wattage ratings listed in the documentation on the side of the power supply. Number and types of connectors that you're going to have. The fans inside the PSU, the power supply unit, and dual voltage options, extra features as well. And a redundant power supply uses 2 identical power supplies. So we'll get into that. You can look at your power supply here and get some of the information about it. So look at the outside and it'll tell you what your wattage rating is on the outside. This one is listed as 360 watts. So that's good to know. It also tells you on the outside that, you know, what the model number is, where it's made, how long your warranty is good for, but it also gives you your range for your AC inputs and things like that. How to calculate wattage capacity. This is important. When deciding what wattage capacity you need, you've got to consider the following: the total wattage requirements, all the components that are going inside your case, as well as the USB devices that get power from the ports connected to the motherboard. Also connected to the motherboard is your fans and things like that too, so keep those in mind. So keep these 2 points in mind when selecting the correct wattage. Video cards draw the most power out of anything in your computer these days. The power supply should be rated to 30% higher than expected needs. So if you expect to have a certain amount, add on that 30% to make sure that you're able to, you know, handle any types of surges that you may need. So to know what size of power supply you need, add up the wattage requirements and add that 30%. So first knowledge check. What is a reasonable wattage capacity for a power supply to be used with a system that contains a DVD drive, 3 hard drives, and a high-end video card? Okay, well, let's think this one through. A DVD, 3 hard drives, and a high-end video card. Well, I'm going to go with 700 watts here because 150 is not going to be enough to power it. 250 is not going to be enough to give us some headroom there. If you were to apply average size to it, you'd probably come out to around 600, maybe 600 watts needed for this. And you need to put on another 30%. So I'd say go with the 700 watts. And the answer was C, 700 watts. So use table 4.2 to add up the approximate wattage: 300 watts plus 30 watts plus the 50 watts. It gives you 470, then add 30% to get 611. So the closest one to that is going to be about 700 watts. So remember to give yourself that 30% headroom in there. And here is the strategies to troubleshoot any problem. This is any computer problem. This is your heuristics diagram. So you start up at the top, question the user, back up the data as you need to. Then you get to the establishing the theory part. So look at the general steps. So you start off with the interview with the user and, you know, backing up your data. Then you establish a theory, you test your theory, then you plan the fix and resolve the problem. Then you verify and prevent, and then you document. And documenting is extremely important. And you will be asked about this in your A+ exam. You'll see the same thing when you're going through network troubleshooting as well. They're going to have a similar heuristic like this. I'm referring to the Network Plus exam, but these things you'll see over and over. They want an organized approach to troubleshooting, whether it's computer or network issues. So do know this general outline. This is going to be important. So steps for troubleshooting, getting back to what we were talking about in the last thing: interview the user and back up your data before you make any changes to the system. Examine the system, analyze the problem, make an initial determination of the source of the problem. Doesn't have to be right, but you have to have a hypothesis. Then you're going to test your theory. And then after you know the source of the problem, you need to plan what to do to fix that problem. And then you need to fix it. So then you need to verify that the problem is fixed and that the system works. Then you need to document your activities, outcomes, and what you learned. And you really should be documenting what you're doing as you're doing it, because if you do multiple things to it, that can get messy. You may forget some of the steps that you took. So document as you go along in that process. Scratch out what doesn't work, go back and work out your documentation as you go. So some troubleshooting resources include the following: the web, obviously, chat, forums, or email technical support. Last resort is usually emailing technical support. And that's usually one of the most lengthy processes because you're going to be bouncing between time zones to get answers on that. Manufacturer's diagnostic software can sometimes be of help. User manuals are helpful. Technical associates in your organization that may have encountered this problem before, not listed in here. Knowledge bases. Sometimes organizations keep knowledge bases for issues that come up with the specific equipment that you work on. So that can be helpful as well. There are 13 troubleshooting rules found throughout the next section. Rule number 1, approach the problem systematically, as we were talking about. Here are the questions you can ask the user. Can you describe the problem? What error messages, unusual displays, or failures do you see? When did the problem start? What was the situation when the problem occurred? What programs or software were you using? What changes have been recently made to the system? Has there been a recent thunderstorm or electrical problem? Have you made any hardware, software, or configuration changes? My philosophy is personally that when you're getting to answers, you'll find that the two most important things to ask in the beginning are, when did this start? And did anything happen around the time it started? Were there any changes made? Because normally when things are working, things continue to work. And then, when acted upon by an outside force, things start to go awry. So that's the way I go about it. But remember, when you're dealing with users, they're often non-technical people. You need to be able to speak to them on their own terms and interpret things that they say. Remember, these are non-technical people often that we work with. So let's be nice to them and let's try to, I won't say dumb it down to their level, but try to put it in words that the layman can understand. So as you talk with the user, keep in mind the following rules. Establish your priorities. Be aware of user error. We often call it PEBCAC. PEBCAC stands for problem exists between chair and keyboard. Keep your cool and don't rush. Don't get upset and don't hurry yourself through anything trying to get to an answer. You can really mess up when you do that. You can skip steps and you can worsen the problem actually. So be sure to back up any important data before you begin work on the computer. Options to back up, you've got Explorer that you can use to copy the data to another system. You can move the hard drive to another system. You can hire a professional file recovery service if you've got hard drive damage. Rules 5 and 6 help as you start solving the problem, and that's make no assumptions. Don't assume anything. Get your information from the user input and what you observe. Try the simple things first before you move on to more complicated possibilities. Sometimes Occam's razor is the answer. Follow this process to form your best guess. Reproduce the problem and observe for yourself what the user has described because you want something that's reproducible. Sometimes it's not, but if you've got a system that intermittently shuts down, you can't really necessarily show that. You need to decide if the problem is hardware or if it's software related. Then you need to make your best guess as to the source of the problem, and don't forget to question the obvious. So the next thing, you need to become a researcher. As you test your theories, you need to keep in mind the following rules. You need to divide and conquer. You need to write things down to keep it straight, because if you're going through a lot of stuff and you have to loop back a lot of times, you'll want to have all that written down. It helps with the documentation as well. Don't assume the worst, and reboot and start over. That is something that one ends up doing quite a lot. And here is another big flow chart when you're facing the problem. It starts off with the begin troubleshooting startup. Does the PC boot to Windows desktop with no errors? No, and you get to the next question. Is important data on the hard drive backed up? So you go through this heuristic chart and this flow chart to decide what to do. And this is something that we've seen. It used to be an uglier version of this, but now it's kind of prettier. It has an ASCII frowny face on it. But the BSOD, the blue screen of death, it's been around forever, and it gives you a little bit of information, often not very helpful, but let's pretend it is. And you can look in there and you can see a URL that will lead you to some information. And if you go down to the bottom, you can see the stop code, and the stop code is really going to help you hone in on what specific area of the system is giving you trouble. When planning and implementing your solution, keep rules 12 and 13 in mind, and those are: use the least invasive solution first. If you're going to do something that's going to make a lot of major changes on it, start with easier solutions first if those are equal possibilities. Know your starting point as well. Know where you started off so you can return to that point. Do the following: plan to your solution and fix the problem. Do the following to plan your solution and fix the problem. Consider different solutions and select the least invasive one first. Give an equal weighting. Before applying your solution, do your best to determine what works and doesn't work in the system so you know your starting point. Fix the problem. If you do not have technical documentation on hand, search the product manufacturer's websites. That goes without saying. This is an example of a manufacturer's website. You can go and get information on hardware or software. Sometimes you can go in like Dell's website or HP's website, and you can get information on the entire system, get the latest drivers for things. Often latest drivers fixes issues. After fixing the problem, reboot the system and verify that all is well. Can you do the following? Reach the internet, use the printer, use Microsoft Office, things that the user needs to do on a daily basis. Sometimes connecting to local storage or network storage. Test those things out. Make sure that the user is good before you leave them. If possible, have the user check everything and verify that the job is done satisfactorily. After verifying all the work, ask the following question. Could this problem have been prevented? Ask yourself this. Don't necessarily ask the user. That could be a little bit prickly. Then you need to document everything. Documentation helps you do the following. Take what you learned into the next troubleshooting situation. So when you have similar problems in the future, you're going to deal with a lot of problems and you're not going to remember everything. Having things written down really helps a lot. You remember, oh, I had a problem with a video card. What was that? If you can go back and search through your documentation for video card, you can pop up that and you can solve it a lot quicker than you did before. Also helps to train others. You're not going to be in your position forever. Other people will come in and take your place when you move up to higher purposes. So it's good to help train other people. It also develops effective presentation maintenance plans or preventative maintenance plans. So that's good. Satisfies any audits or customer employee queries about your work. So there's a record of what you've been doing, keeps the bosses happy. Be sure to include the following items in your documentation. You want the initial symptoms, source of the problem, and your troubleshooting steps. So the following are possible symptoms of a problem with the electrical system, and that could be the computer appears dead, no indicator lights, no spinning drive or fan. The computer sometimes locks up during booting. Error codes or beeps occur during the boot process. You smell burnt parts or odors. That's never a good thing. The computer powers down at unexpected times. The computer appears dead. Did you hear a whine coming from the power supply? Here are some questions to ask and things to do to solve a problem with the electrical system. If you smell any burnt parts or odors, don't try to turn the system on. This is common sense, but it's not always common to some people. So keep that in mind. Do not try starting it up if you smell burning stuff. It's only going to get worse. So when that happens, you identify the component that is fried and replace it. Sometimes, look on the motherboard, see if you've got capacitors that may have burst. That's something that happens from time to time, especially in older computers. When you first plug up power to a system and hear a whine coming from the power supply might be inadequate for the system, or there might be a short. Is the power cord plugged in? This is actually something that happens. Sometimes the cable from the back of the power supply may get wiggled loose when it's been moved around, or if people have a system on their desk and they move the desk around a lot, that could wiggle loose. Is the power outlet controlled by a wall switch? Does the wall switch set that off? Are any cable connections loose? So if you need to look inside the computer to turn it off, as we've talked about before, unplug it, press the power to drain the residual power in there, and only then should you open the case. After doing that, you'll check all the power connections from the power supply to the motherboard and drives. If you smell burnt parts, carefully search for shorts or frayed or burnt wires. Also look for burst capacitors and things like that on the motherboard itself. If you suspect the power supply is bad, test it with a power supply tester. Those aren't that expensive. You may have to order it online. I'm not sure if Best Buy and places like that carry it locally. Here's some problems that come and go and are a little bit more difficult to nail down. So the computer stops or hangs for no reason. Memory errors appear intermittently, but not on a regular basis. Data is written incorrectly to the hard drive, or files are corrupted. That's a painful one. The keyboard stops working at odd times. The motherboard fails or is damaged. The power supply overheats and becomes hot to the touch. The power supply fan whines and becomes very noisy or stops. So here's what to do to eliminate the electrical system as the source of an intermittent problem. You need to consider whether or not you've got enough juice. Is your power supply adequate enough to power all the devices that you have in the system, counting everything that's in there, including your fans and whatnot. Also, you should suspect the power supply could be faulty. The power supply fan may not work. If the fan in the power supply doesn't work, do not try to fix it. And do not, the fan in the power supply, you don't want to open that up. That's more of a just replace it kind of thing. Don't operate the system though if the fan on the power supply isn't working. That's just not going to go well. A short might occur if some component on the motherboard makes improper contact with the chassis. That can happen if metal comes in contact with some of the traces or something like that. For some cases, check for missing standoffs. The standoffs are where the motherboard goes onto the chassis itself. There are these little metal posts. So sometimes you could have some issues with a standoff not being used, and you could have some kind of an improper connection because of that. You can shake the case gently also. Sometimes if a screw comes off or a screw wasn't put in and it shook off somehow or loosened up, if you kind of loosely, shake the chassis, if you've got the strength to do that, you might hear screws rolling around in there. That is something that, I've often heard. Or you can have little tiny pieces of metal that went into like your IO port or something like that. Sometimes a little piece may shake loose or something like that. If it lands on your motherboard, it could be, shorting something out. So do a little gentle shake to see if you hear anything rolling around in there. Shorts in the circuits on the motherboard might also cause these problems. Look for damage on the bottom of the motherboard. Look for burnt traces and things like that. Some of the symptoms of overheating: you've got a system that'll hang or freeze at odd times or after the boot starts. You'll get the Windows BSOD, the blue screen of death that we talked about earlier. You can also not hear a fan running, or the fan makes a whining sound. Those are indicators. Or you can't feel the air being pulled into or out of the case. That's another indicator. If you suspect that that it's overheating, go into the BIOS, the UEFI setup, and view the temperature monitors for the system. See what your different temperatures are in different places. You can also put in a temperature sensor that will sound the alarm when the inside of the case gets too hot, if you're trying to figure out in normal usage, when you're getting a situation where you're just baking the insides. So things you can do to solve the overheating include the following. If your system hangs, go into BIOS UEFI setup and find the CPU screen that reports temperature. It shouldn't exceed the recommended CPU, the temperature recommended by the CPU manufacturer. You can use compressed air, blower, or anti-static vacuum to remove dust from the power supply and vents. Again, like I said in previous lessons, dust can be a killer when you get it, coating certain things that need to be able to dissipate heat. So make sure that your different things like your heat sink on your CPU isn't clogged with dust. I've seen that happen. Check the airflow inside the case to see if the fans are running, and you may need to replace a fan. Also, make sure that you've got them in a way that is effectively blowing air through your case. You want good airflow through there. So make sure that you've got them pointed in the proper way to get air flowing through your case. You can install extra fans if the case will hold them, if there's a place to put them so that they'll actually vent out. You can also install a chassis air guide that guides air to the processor. You can also improve the airflow by replacing missing faceplates and expansion slot covers. Here is an example of a very crowded box here. So it says use cable ties to hold cables out of the way of fans and the airflow, and that's a good thing. Cable management is something we talk about a lot more these days than we did in the old days. Talk about this particularly in networking as well. Good cable management, keeping your cables and your wires out of the way where they're not going to cause trouble, not going to mess with other things or shake other things loose. It's good to have everything tied down as much as you can using little cable ties. So keep that in mind. So problems with overheating continued. Things to do to solve overheating include the following. Place the case so that there are a few inches of space on both sides and the top of the case. Verify that the cooler is connected properly to the processor. That's important. After closing the case, leave system off for at least 30 minutes. Check the UEFI BIOS setup to see if the processor is being overclocked, because that can cause the system to overheat. As I've mentioned before many times, overclocking can lead to odd behaviors, unexpected behaviors, as well as damage to processors, so be careful. Also, have you installed too many peripherals inside the case? Try to leave an empty slot between each card if you can, if there's enough room. Otherwise, you're going to have a lot of hot things in dense areas, and that can that's not very good. Flash your UEFI BIOS to update firmware on the motherboard. Make sure that everything's up to date. Here is some examples of good airflow. If you look at the one on the bottom, you can see that you have airflow on the bottom, which represents the front of the case. It's sucking air in there and it's blowing it out to the back. And in the back, you've got two different places. One is the power supply that is blowing air out, and the other is the exhaust fan in the back. So you want good flow so that it goes across it. If you look at the one on the right, you have relatively bad flow because you've got the side vents that are taking in air, but there's nowhere really for it to dissipate. You've got the power supply, which is going to put out a little bit, but yeah, there's nowhere else really in here that's set up to vent. So with laptop systems, a laptop can be powered by an AC adapter or a battery pack. Today, it's mostly lithium-ion technology that's involved there. Most AC adapters are capable of auto switching from 110 to 220 volts. So if you ever travel to Japan, let's say, you're not going to have any trouble. Some mobile users like to keep an extra battery on hand in case the first one uses up its charge. I don't know anybody that does that really. I just know people that go around and they keep possibly their battery pack, should things go awry. But yeah, continuing on. So if power is not getting to the system or the battery indicator light is lit, do the following. Verify that the AC adapter is plugged into a live electrical outlet. Check if the AC adapter's plug is secure in the outlet. Check connections on both sides of the AC adapter transformer, because that may be why it's not giving power. Then you need to check the connection at the DC jack on the laptop. If the battery is not charging when all that's plugged in and checked out, the problem might be with the battery or the motherboard. So the following symptoms can indicate the motherboard processor or motherboard memory is failing. And that's the system begins to boot, but then powers down. An error message is displayed during the boot. The system reports less memory than installed. The system becomes unstable, hangs or freezes. Intermittent Windows or hard drive errors occur, or components on the motherboard or devices connected to it don't work. So you want to check the simple things first. And then if an error message appears, Google that error message. That's the common sense first line right there. Google the error message that you're getting. Then you can also run antivirus software to check for viruses. Sometimes viruses can cause trouble that slow down your computer or make it act very strangely. A memory module could be failing, so you can use a memory diagnostic tool to test memory. You should check for potential hardware problems using the device manager. Go in there. Often, if you've got a problem with a device in there, it's going to open it up, it's going to expand it out, and you'll see like a yellow exclamation mark beside the offending device. You can use that, figure out which one it is, and then try to replace that. You can also check your event viewer logs for a record about hardware or application problem. If you go into system, I believe, you can find things that will cue you into what's going on. Look for the red marks in there. So in Windows, download and install any Windows updates or patches. Always want to be patched up to the latest, greatest if your software will support it. Sometimes people may have a system that's going like a server and they don't want to patch it to the latest for various reasons, compatibility wise. So be careful of that. If the system began after a change or a new install, uninstall the device or application, try to undo the process that led you to this problem. You can also use the Windows About window to find out how much RAM is installed, considering upgrading if it's not enough. You can check the BIOS UEFI setup to ensure the proper settings. You can disable any quick booting features in BIOS UEFI. Then you can look for the errors during the boot process, because otherwise, if you're just doing a quick boot, you may not see those error messages popping up. You can flash the BIOS UEFI to update firmware on the board. You can check the motherboard manufacturer's website for diagnostic hardware. That can sometimes be of help. Not all the time, but sometimes it is. Update all drivers of motherboard components that are not working. Don't go and do everything necessarily. There's sometimes a, if it ain't broke, don't fix it kind of approach to take here. But if it's affecting things that are related, even if it's indirectly related to the parts that aren't working, you may want to update those firmware drivers if available. So if an onboard port or device is not working, verify the problem is not with the device using that port. Go into the BIOS UEFI setup and verify that the port is enabled. You want to make sure that that's an embarrassing one to miss. Check your device manager and verify Windows recognizes the device of the port with no errors. Again, look for those yellow exclamation marks. Update your motherboard's drivers for the device or port from the manufacturer's website. Use a loopback plug to test the port, and disable the port in BIOS UEFI and install an expansion card. That's kind of a last case thing where you can, well, if it's not working, we'll just go ahead and install the capability through another expansion card. And that, of course, is only if you have room for that. If you've already got a full case and you don't have room for it, then that's not going to be an option for you. Next, suspect the problem is a failing hard drive. That does happen. You could also suspect that the problem is caused by overheating. Verify the installed processor is supported by the motherboard. Sometimes people haven't followed the instructions when buying motherboards and matching it with processors and memory. So that could be an issue. Personal story here, I have a MacBook Pro and I had some problems running certain software that's very, very processor intensive. And I was finding that even though the MacBook Pro was supposed to have really good passive heat dissipation, it didn't. And I was getting dust that would accumulate in the vents. So I, to this day, still every other week or so, I'll take a Dyson vacuum with a brush on it and I'll brush it really thoroughly to suck out all the air I can. And you can go to Apple and have this done, but they'll take your system out of commission for about 2 weeks to do it. And I personally don't want to open up a MacBook Pro. There's a lot of other things I would like to do in life besides that. So if you can fix that on your own, it's worth it. And I find that a Dyson vacuum with a brush attachment is good enough to clean out the vents on my MacBook Pro. So many continuous restart errors can be solved by performing a startup repair process. The startup repair utility restores many of the Windows files needed for a successful boot. So you can follow the steps to run startup repairs from Windows, set up using USB or DVD. If necessary, change the boot priority order in the BIOS UEFI setup so you can actually use that. Otherwise, it's just going to default to your hard disk and you're going to go right through it. So if you've got that USB plugged in, it's not going to use it. So change your boot order to get that to work. Then on the opening screen, select your language and click Next. On the next screen, click on Repair Your Computer, and then choose Troubleshoot. So on the advanced options screen, choose the Startup Repair. So that's the process for doing that. And our last little knowledge check here is going to be situational. It's someone asks you for help with a computer that hangs at odd times. You turn it on and work for about 15 minutes, and then the computer freezes and powers down. What do you do first? Well, I think the key here is first. Do you first replace the surge protector? I don't think so. Surge protector is keeping it protected from bursts that come through, and it shouldn't shut down. Replace the power supply? Power supply could be at fault here, but is that what we're going to do first? Well, let's look. The second thing is wait about 30 minutes for the system to cool down and try again. That sounds really good to me. And the reason for that is we don't know what just happened. And if the system has gotten really hot, if we wait 30 minutes for the system to cool down, we can try again and see if similar behavior happens, because supposedly this just happened out of the blue. So we need to find out if this is a repeatable problem. And the last thing is install an additional fan. Again, B and D might be the ultimate solution. A doesn't sound like it's related. B and D could be an ultimate solution. But again, what do you do first? These are not things you're going to do first. I say it's C. And yes, the answer is C. We're going to wait about 30 minutes for the system to cool down and try again. So it says, given the computer symptoms described, you might suspect possible overheating. The first step is to get accurate temperature readings after cool down, and again later when the system is overheated. So this is how you go about starting your troubleshooting process. So in summary, now that the lesson's ended, we should be able to describe the methods and devices for keeping a system cool, select a power supply to meet the power needs of our system, demonstrate an organized approach to solving any computer problem, especially hardware problems occurring during the boot. And remember, these processes are repeatable, systematic, and they're things that we can apply to the computer problems as well as later on if you're working on the Network Plus. This whole idea of having a system a methodology about going back about the troubleshooting process, you'll find this is used in other places as well. So keep this in mind. Troubleshoot problems with the electrical system, and you should also be able to troubleshoot problems with the motherboard, processor, and RAM. And that concludes our chapter. If you have any questions about any of the material here, feel free to reach out to me and I'd be happy to answer it for you. Until we meet again, have a great week. Aloha.